Hello, grade 12s, matriculants. It is your chance now. This is Learn Extra Live with me, Abraham, and I'm not alone. I'm with Natasha. How are you?
Hi, I'm good, thanks. How are you doing?
I'm all chill today. Everything is smooth.
Good.
Trust me, I'm pashash. Are you ready?
Yes, I am. So, guys, to let you know what we're doing today, we're looking at the last section of calculus. So, we're doing part 4. We've done quite a lot of calculus over the last 3 weeks. So, today we're going to sort of round everything up and do applications of calculus, which a lot of you love to hate. So hopefully not so by the end of this lesson. So I'm going to take my cue and make my way over there while Abraham lets you know how to get in touch.
Please do that.
Right?
Yes, of course. Right, Mindsetters, first 3 things is that today it is our Triple M day, which is Mindsetters Maths Monday. It's all about maths. Matriculants, I know that you're up and ready for this, but the last 3 things that you need to know is that 1, you can join us on Facebook, chat with us, ask us any questions that you have or comments that you might be having. Our Facebook link is facebook.com/LearnExtra. 2, you can tweet us on Twitter at LearnExtra. And thirdly, lastly, you can just download the notes for free on our learnextra.co.za/live. I'll also make sure that I post the first link on our website to make sure that you are also having the same notes that Natasha is going through. But also, Mindsetters, remember, on our Facebook page, we have a competition running whereby you could just guess. When do you think we can hit our 42,000 likes? Make sure that as you're guessing, you also tell your friends to like our Facebook page, and you might be winning yourself this wonderful and awesome Mindsetter t-shirt. For now, Natasha, let's learn.
All right, guys, so glad you can join us once again with calculus. This is part 4 of the calculus series that we have been doing over the last few weeks. We've looked at all the different reasons we need to derive. Just to remind you guys, we looked at calculus graphs, we looked at tangents, and we looked at finding the gradient of a graph. So today we're just going to look at applications of calculus and see those questions that a lot of you don't really like, which is applying calculus to graphs and then to maxima and minima problems and rates of change. Okay, so that's exactly what that says. We're just going to look at maxima and minima and rates of change and also cubic graph applications. So we're going to get stuck straight into the questions, starting with a question from a past exam paper, and this is from the February-March supplementary exam from last year. If you do have that paper, and I mean you certainly have this link on the Facebook page as Abraham said, so you can look at it there. But if you have the paper as well, you can follow in that. And this is question 9 from that paper. Let's get started. Okay, so they give us the graph of f of x, which is your calculus cubic graph, ax cubed plus bx squared plus cx plus d. And then they give you the straight line, g of x is equal to 6x minus 6. They tell you that's sketched below. They give you the point A, minus 1, 0, and they give you C, 3, 0, and those are the x-intercepts of the calculus graph. They tell you that the graph has a turning point at A and B, and D, 0 and negative 6 is the y-intercept of F. E and D are points of intersection on the graph. Okay, so everything that's in the given information is basically in your diagram. You've got your turning points at B, turning points at A, which also happens to be an x-intercept, another x-intercept at C, which is the point 3 and 0, and then you've got D being your point of intersection of the 2 graphs. Okay, and it's also the y-intercept of both graphs. So the first question says, and this one is for 5 marks if you are following along in your paper, show that A is equal to 2, B is equal to negative 2, C is negative 10, and D is equal to negative 6. So in other words, they want you to find the equation of your cubic function. Okay, now guys, let's have a look at the graph. Okay, we've got to see what we've been given. We've got the point A here, which is an intercept and a turning point. We've also got the point C, which is an intercept, and we're going to use those 2 points to help us get the equation of the cubic function. Okay, so this is part A. And we're looking for the equation of f of x. Now, you'll always set this up, depending on what you've been given, but we're generally going to set this up as f of x is equal to A, which is the unknown, we don't know what that coefficient is, times x minus x1 times x minus x2 times x minus x3. And we're generally going to set it up this way if we've got x-intercepts to work with. All right, x1, x2, and x3 are the roots of your cubic function. So those are the x-intercepts. Now, what you'll notice on the graph is that at the point A, all right, and I'm just going to highlight it a bit better so you guys can actually see that that is what is the coordinates of A. So A is the point minus 1, 0, but you'll also notice that it's also a turning point. So it's not only an x-intercept. So it's actually a repeated coordinate on your graph. It's an x-intercept and a turning point. So because of that reason, you're going to have x minus x1 and x minus x2. Those are going to have the same x values. Okay, so the two roots are going to be equal because you have a turning point that's also an x-intercept. So you're going to get x minus, use brackets so you don't get your signs wrong, minus 1. And then the other x-intercept you have was 3 and 0. So that's the point C. So we're going to substitute x3 as 3. All right. Now, let's just simplify this a little bit. Minus times minus is going to give me plus. All right, and remember, and I've already forgotten to put it in, but hopefully you guys realize that because it's an x-intercept and a turning point, we're going to have the coordinate x plus 1 squared times x minus 3. All right. Now, we need to find A, the coefficient of this cubic function f of x. If we've got the value of A, right, we can then take that value of A, times it through the brackets, and we'll get all the coefficients. We'll get A, B, C, and D. So getting the correct value of A is the most important part at this point, because if you get the value for A wrong, your B and C and D are also going to be incorrect. So be very, very careful. All right? The only thing we can do to find A is substitute another point from the graph. And the only other point we've got is that point D, which is 0 and negative 6. So into this equation, I'm now going to substitute D, which is the point 0 and negative 6. Okay, so x is 0, y is negative 6. F of x, your function value is negative 6, is equal to A times x. Remember, the x coordinate is 0, so we're going to get 0 plus 1, which is just going to give me 1 squared. And then we're going to get 0 minus 3, which is just minus 3. All right, so we get negative 6 is equal to A times 1 squared is just 1. 1 times negative 3 is negative 3, so it's actually just negative 3A. Okay. We're looking for A, so we divide both sides by negative 3. Negative 6 divided by negative 3 is 2, so therefore A is equal to 2. Now that we have that value for A, we're going to take that and substitute it back into this line and multiply out to get the values for B, C, and D. So f of x is equal to 2 times x plus 1 squared times x minus 3. All right, so this is going to be 2 times x squared plus 2x plus 1. I'm just simply multiplying this first bracket out times x minus 3. And then we distribute, so we're going to times the x through the first bracket and then the same thing with the 3. So I'm going to get 2 times x squared is x cubed plus 2x times x is plus 2x squared, and then x times 1 is positive x. Okay, now let's do the 3. Minus 3 times x squared is minus 3x squared. Minus 3 times positive 2x is minus 6x. And minus 3 times positive 1 is negative 3. We then close the bracket and we're going to multiply that 2 into the bracket and simplify. Okay, let's just add our like terms firstly. So we've got x cubed 2x squared minus 3x squared is minus x squared, plus x minus 6x is going to be minus 5x minus 3. Now we times the 2 into the bracket, so we're going to get 2x cubed minus 2x squared minus 10x minus 6. All right, so from there we can say the value of a is equal to 2, right? That's the coefficient of x cubed. The value of b is negative 2, and c is negative 10, and d is equal to negative 6. And if you go back up to the question, you'll see that they asked you to prove exactly those values for a, b, c, and d. Also, when we found the value of a, you must just remember, always keep thinking about what you're doing. So remember, we got a positive value for a, and it makes sense because our graph has the shape that a positive value of a implies. So we have first a maximum turning point and then a minimum turning point. Because remember, last week we discussed that if a is greater than 0, then we're going to have a graph that has a maximum and then a minimum. And if a is less than 0, we're going to have a graph with a minimum and then a maximum. So the shape and all of that, you must keep that in mind so it makes sense. Okay, now that we've got the equation of f of x, we're ready to answer the rest of the questions, and I hope that all of you are following with me and you've all got the same answers and we're on the same page. Okay, the next thing we're going to do is calculate the coordinates of the turning point B. Remember, to find a turning point or the stationary point, you have to derive and make your derivative equal to 0 and solve for x. Okay, so let's have a look and see how we find the coordinates. All right. So we're going to use our equation. So this is part B. We've got 2x cubed minus 2x squared minus 10x minus 6. So I'm looking for the stationary point, so therefore I need to take the derivative of f. And I'm deriving this equation here that's up on the top of the screen. So if I derive that, I'm going to get 6x squared minus 4x minus 10. But remember, because we're looking for a stationary point, we need this derivative to be equal to 0. Because remember, when your graph is turning, the stationary point, when you're at a stationary point and your graph is turning, your derivative is 0. So your graph is neither increasing nor decreasing at that point. Okay, you will remember that from the previous lessons. All right, let's divide through by 2, so we make this a little bit easier. So it's 3x squared minus 2x minus 5. And we can factorize that into 3x times x, and we need to get a minus 2, so we need a minus 5 and a positive 1. Okay, so therefore we're going to get x is equal to 5 over 3 or negative 1. And it's important that we've got that negative 1, because remember, if you go back to the diagram, one of the turning points was negative 1 and 0. So when you work out your stationary points, this has to be one of your answers. So we know that we're on the right track. So B is obviously the other one. So therefore B, the x value at B is 5 over 3. We need to find the y value, so we take that and substitute that into, because remember, whenever they ask you for a stationary point, you're looking for coordinates. So we need to substitute that back into the function, into the original function. Okay, so into that one. So I'm going to get 2 times 5 over 3 cubed minus 2 times 5 over 3 squared minus 10 times 5 over 3 and then minus 6. All of this you will just put into your calculator and let's see what we get. All right. So we've got 2 times 5 over 3, oopsie, 5 over 3 to the power of 3, so we're going to cube that, minus 2 in brackets, 5 over 3, and then we're going to square that one, minus 10 times 5 over 3 minus 6. Okay, and you get minus 512 over 27. Remember, you can press the S to D button to get a decimal. So it's negative 18,96. Okay, negative 18,96. So those are the coordinates of the turning point B. It's 5 over 3 and negative 18,96. Your calculator's obviously made it so nice and easy to work that value out. All right, so hopefully you're all still with me and you're all still awake and you're ready to do the last part of this question before we take a break. All right, I hope that you all still have your thinking caps on because this one requires a little bit of thinking. Okay, so this is part C. They say find h of x, which is the vertical distance between F and G. So let's have a look at your graph. All right, there we go. So we want to find the vertical distance between F and G. So we're talking about that distance there. Obviously, it's variable. It depends on which points you're taking, right? Because obviously at some points, the straight line's above the cubic function and then the other way around. Sometimes the cubic function is above the straight line like it is on this side. So we need to find that length which can, as you can see from the yellow lines I've drawn, that length can vary. Okay, it can vary. So we just want to find the vertical distance, which they've called hx, which is f of x, cubic function minus straight line. But we just don't want any old distance. We want to calculate x such that h of x is a maximum. And they also tell us where x is less than 0. Okay, so a little bit of information there that they've given us, and a few clues. So we know that h of x is f of x minus g of x. They want us to find h of x such that it is a maximum distance between the two graphs. Now remember, using calculus, if you're trying to find a maximum, or later on, as you will see in the lesson, when we're trying to find a minimum, what do you need to do? Abraham, what do we need to do?
Could we have covered that one?
I caught him very off guard. I could see him very busy on the page, and I just wanted to keep you on your toes.
Please.
Okay, so Abraham's still awake. Hopefully you all are still awake as well. Remember, if you want to find a maximum value using calculus, you need to find the derivative and make the derivative equal to 0. Okay, we need to then solve for x, and you'll see that in this question they say where x is less than 0. That's a clue, because it could mean that you could get two x values, and we're obviously going to choose the negative one. All right, so first let's set this up. So we know that h of x is equal to f of x minus g of x. Now, in order to get any kind of equation, we need to remember what f and g were. So let's go right back to the top here. F we had is 2x cubed minus 2x squared, so it's 2x cubed minus 2x squared minus 10x minus 6. And then g, we haven't really used much, but they did give us that equation right in the beginning of the question. They said that g of x is equal to 6x minus 6. Okay, so in place of gx, we're going to say 6x minus 6. All right, so we're going to get 2x cubed minus 2x squared. Now remember, with this negative, we need to times that into the bracket and change our sign. So this is going to become negative 6 and negative 6x plus positive 6. Okay, so it's going to be minus 2x squared minus 10x. But then we're going to minus the 6x from within that bracket. So we're going to get minus 10 minus 6, which is minus 16x. All right. And then we've got minus 6. And then a minus times a minus is a positive. So minus 6 plus 6 from within the bracket. And that's going to give us 0. Okay, so therefore the distance h of x is 2x cubed minus 2x squared minus 16x. We need to find what value of x would maximize that expression, so we need to derive. All right, so I'm going to get 6x squared minus 4x minus 16, and we're looking for the maximum, so we need to make that equal to naught. All right, divide through by 2 if you want to make your equation a little bit easier. So we're going to get 3x squared minus 2x minus 8. Okay, and let's factorize that. So we get 3x times x, and factors of 8, we can use 4 and 2. Let's just check what's going to work. If I have 4 and 2, and I need to get a minus 2x, so it's going to be minus 2 and positive 4. All right, so we've got x is equal to negative 4 over 3 from the first bracket, or if we let the second bracket equal naught, we get x is equal to 2. Okay, but remember the clue from the question. They said x must be less than naught. That comes straight from the actual question. So therefore, we obviously don't accept the x is equal to 2. That's not going to give us the maximum that we're looking for here. We're going to take negative 4 over 3 as my value for x. So therefore, x is equal to negative 4 over 3 is the value of x such that h of x is a maximum. Guys, and you're going to stop there because they haven't asked you to now go and find that maximum length. So you're not going to take that value for x and put it back into your expression for h of x. Don't make that mistake. You're just making more work for yourself, and it's not going to be marked because the question stops as what is the x value. We were just calculating x to maximize that length. Okay, I hope that you all really understood that question, and that was our cubic function application question for today. When we come back, we're going to do a lot more applications of calculus.
Thank you so much, Natasha. You know, on the page, I just cannot help myself. I've been laughing all over, but there's a joke that has been posted by one of the Mayan cities. His name is Gabelo DJB Mpatlele. I just want to say this. If you're having a bad Monday, a stressful Monday, and you just want to laugh, go over our Facebook page. It is facebook.com/learnextra. There's just a wonderful joke there, and you're just going to laugh your lungs out, just like I did. But a very important thing that you need to know as a grade 12 learner, a matriculant that we love as Mindset, on Saturday, we're going to be having a Saturday show just to help you through from 9 o'clock up until 10:30. It's going to be mathematics. But throughout the whole day, we'll also be having other subjects up until 1:30. So make sure that you tell all your friends that on Saturday, it is happening. But for now, it's happening right here, and we'll see you after the break. Welcome back, matriculants, and now over the page, I've asked you a simple question. What words define your own triple M? Because my triple M is Mindset's Math Monday, and I've asked a couple of Mindsetters, and I have some replies, and I'll also ask you, Natasha, right? What's your triple M? Steffi says, must manage Mondays. I like that. And Benny Bena Mathalela says, make me matured. That's what Mindsetters do. It makes people matured. What is your triple M as we continue?
I think mine is going to be maths makes me.
Oh, yes. I like that. Very creative. Let's continue. Thanks.
All right, great. So obviously, Abraham, we're having quite a lot of comic relief on the side there on the Facebook page. Glad that you're all keeping him entertained, but I hope that you're all working really hard as well. Okay, so remember, today we're looking at applications of calculus. In the first part, we looked at a cubic graph application question, and now we're going to carry on with a section for some reason a lot of people don't really like, and that's maxima and minima. And guys, the only way you're really going to get better at anything in maths is just to practice, 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 as I keep saying. But also with this specific section, you need to know your formulae. You need to know how to find area. You need to know how to find perimeter, volume, total surface area, and all of that. You have to know those formulae to be able to do this section. Okay, the formulae for area of a triangle, that's not going to be given to you on your formula sheet. You need to know that in your head. Okay, but what I have given you is just the formulae that I find useful. Now, I know a lot of people, they like to do tessellations, which basically means you break up the figure. Okay, you find each of the little surfaces and then you work out the volume and the surface area and all of that. But I use these formulae to work out volume and total surface area. It works for me all the time. I prefer using this method to find volume and total surface area. If you don't like it and you like splitting your shape up into 2 circles, 2 rectangles, or whatever the case is, please go ahead and do it if that's what you're comfortable doing. I just find that these are 2 formulae that I just learn off and makes doing any kind of maxima and minima problems or any kind of volume and total surface area very, very easy. Okay, and you'll see why. All right, so the first one I like to use is volume is equal to area of the base of the shape times the height. Now this goes for any 3D shape. Okay, it doesn't matter whether it's closed or open. So the volume is equal to area of the base times the height of the shape. That means if you identify the base of the shape, okay, all you need to do is find the area of that base, times it by the height, and you've got the volume. So if we're looking at a cylindrical kind of shape, and obviously not judging my drawing, which is not that great, but if you're looking at a cylindrical kind of shape, then your base here is a circle. So if you wanted to work out the volume, you'd find the area of the base and times it by the height. Okay, it would work the same way for a cube or anything else. All right. Then for total surface area, and I really like this one because you don't have to break this shape up into 2 circles, 2 rectangles, etc. Your total surface area is equal to 2 times the area of the base. Again, all you've got to do is identify the base. So it's 2 times the area of the base plus the perimeter of the base times the height. Okay, so if you know your basic area and perimeter formulae, this is really, really easy to apply. These formulae, if you do want to use them, you need to remember them off by heart. They will not be given to you. This total surface area formula, which is 2 times area of base plus perimeter of base times height, that's only for a closed shape. Okay. If they tell you, for example, if it's a can and they say, okay, the can is open, there's no top bit, all right? So you don't need material to manufacture that little top bit. All you would do for a shape like that is you drop the 2 because you no longer have 2 areas of bases. You've just got one base, one area of a base to contend with, okay? Because remember, you can flip this over. So either this could be the base or that one, right? But if you've got an open shape, that means that we don't have this top bit, so we only concentrate on 1. So therefore, if we're looking at an open can or an open shape, you know, they might say the lid of the box is open or something like that, or there's no lid or whatever the case is, then you drop the 2. So then your total surface area stays exactly the same. You just drop the 2, so it becomes area of the base plus perimeter of the base times the height. Okay, so if you are willing to learn just these 2 extra formulae, then I think that maxima and minima can be made really, really easy. You know, if you already know your area and perimeter formulae for all your other shapes, learn these 2 more. It makes application very, very easy. Now, whatever method you are using, if you don't want to use mine, absolutely fine. I will not be hurt. You can go ahead and do it the way you like and the way you prefer. But the questions that I'm doing today, these are the formulae that I'm going to be using. Okay, so let's get on to question 2. Right, they tell us that the radius of the base of a circular cylindrical can is X centimeters. And they then say that its volume is 430 centimeters cubed. Okay, so you're talking about some sort of cylindrical can, right? There we go. And they tell you that the radius of the base So if I say this is my base here, so the radius there, they tell you that that is x centimeters. All right, so your radius is x. They also tell you that the volume of the can is 430 cubic centimeters. Okay, the first question says determine the height of the can in terms of x. All right, so we're going to use the formulae that I've shown you already. Okay, so this is part A. Now they've given us that the volume is 430, right? They've also told you that your radius is equal to x, and we know that we're dealing with a cylindrical can. All right, so therefore, applying my formula, I know that volume is equal to area of base times the height. Okay, remember the base here is a circle, and remember the area for a circle is pi r squared. That's how you find area of a circle. So the area of this circular base is pi r squared. We then times that by the height, and that gives me an expression for the volume. But remember, they've also told you that the radius is x, so this will become pi x squared h. Okay. They have told you that the total volume is 430. Okay, so therefore I know that my expression for volume must be equal to the total volume of 430. They want you to find an expression for your height in terms of x. In terms of x means there must be an x in the answer. Okay, so therefore we divide away to get the h by itself. So we divide by pi x squared. So we get h is equal to 430 over pi x squared. Okay, and that is the first part. That's the expression for the height in terms of x. Now guys, please don't get confused with this pi. All right, pi is not another variable. Pi is not like an x or a k. Pi has a value. Remember, you learned this long ago, that pi is equal to 3,14, so on, and they're still calculating the decimal places to pi. So pi is an actual value. It is not a variable. So therefore, don't get confused with working with pi. We're really dividing by a number. Okay. So our expression is h is equal to 430 over pi x squared. All right, let's look at part B. All right, now they're talking about area. They say determine the area of the material needed to manufacture the can. And they've even explained it to you. They're really nice and said, that is, determine the total surface area of the can in terms of x. In terms of x means we don't want an h in it. All right? Now, why is it important that we say we don't want an h? Because we found an expression for h, and we're going to see that this value pops up again in your total surface area formula. Okay, so you're not going to leave the h in there. You're going to replace it with this expression that we have for h. Now, when we're working out the total surface area of the can, remember we're talking about the material, the actual metal material, okay, the tin. Okay, that's what we're talking about. We're not talking about the covering or the wrapping that's going around the can. We're talking about the tin and the metal that's required to make that can. That's what they want you to find out. Okay, so let's get started with part B. And this is the total surface area. This can is going to have a lid on it, so therefore the formula to use is 2 times the area of the base plus perimeter of the base, and then we times that by the height. Now remember, here we're dealing with a circular base, so therefore it's going to be 2. Area of your circle is pi r squared. Okay, so it's 2 times pi r squared plus perimeter of a circle. Now this is what I was saying to you. You need to remember these kinds of things. It's not going to be given to you. The perimeter of a circle is 2 pi r, or pi d. Okay, so you can either say 2 pi r or pi d to find the perimeter of the base, and then we times that by the height. Now please don't ask me where did I get that from. You need to know that. You've been learning that hopefully since grade 8. Okay, now let's replace things. We know that r is equal to x. So therefore we get 2 pi x squared plus 2 pi, remember r is x because they told us so, so I can say it's 2 pi x. And then the height we worked out previously, that is 430 over pi x squared. Okay, so the height is 430 over pi x squared. Okay, remember you want everything just in terms of x because the question says find your answer in terms of x, so we don't want any other variables. Okay, so I'm just simplifying, so I'm going to get 2 pi x squared plus, let's have a look, this pi in the numerator and that one in the denominator, they would cancel. X will go into itself once and x goes into x squared once, x times. So therefore I end up with 2 times 430, which is 860, all over. The pi's have cancelled, x has gone from there, and we've just got an x. Okay, so therefore my expression for total surface area just in terms of x is 2 pi x squared plus 860 over x. It's important to get this expression correct because as you will see in the questions that follow, we need this expression to answer the rest of the questions. Okay, so let's get on to part C. Okay, now here they start talking about least. Okay, so this one's slightly different. Usually we hear about minimizing, but another way to say minimize, we can say find the least. So determine the value of x for which the least amount of material is needed to manufacture the can. So remember what I said to you, least is the same as saying minimizing. Okay, so therefore if I want to minimize something in calculus, I need to find the derivative. Now they're talking about the value of x for which the least amount of material. Now remember material, we're talking about the question we just did where we were looking at the amount of material in terms of x. So we found the total surface area. So if I want to find the value of x for which the least amount of material is needed, I need to derive my expression for total surface area. So I need to derive this expression. Okay, so this is part C. All right, so I'm going to derive my total surface area. So if I just call it A is for area, I'm now going to find the derivative of that. So 2 times 2 is going to give me 4 pi x. All right, now with this one, remember before you derive, and we did this in a previous lesson, you need to get rid of your divide signs and brackets and all of that. 860 over x is the same as 860 times x to the minus 1. Okay, using your laws for exponents. So over x is the same as x to the negative 1. So that's the expression you're deriving. Okay, not the one where the x is in the denominator. All right, so we're going to derive that. We're going to get minus 860 times x to the minus 2. Hopefully you all know your rules for deriving by now. Okay, so that's our derivative. We want to minimize, so this derivative needs to be equal to 0. Okay, so I've got 4 pi x. Now to simplify this, it is actually easier to do it by writing the x to the minus 2 in your denominator. So it's going to be 860 over x squared, and that's just using exponents. X to the minus 2 is the same as 1 over x squared. Okay, find an LCD of x squared. So this is going to become 4 pi x cubed, because remember your first expression is over 1. So I times through by my LCD of x squared. So I get 4 pi x cubed minus 860 is equal to 0. And now we need to solve for x. So we've got 4 pi x cubed. Take the 860 to the right hand side. And we need to solve for x, so we divide both sides by 4 pi. Remember, pi is just a number. So we're going to get a value here, right? And we want x, so we need to get rid of the cube, we need to take the cube root of that entire fraction. All right, so let's do this in our calculator. So we've got, we want to find the cube root of 860 over 4 pi. Okay, what we're going to do is I'm quickly going to do the answer. I think it is time for a break, so I'm quickly going to do the answer for you while we do the little break, and I'll come back and show you what the answer is.
Right, Natasha, Mindsetters, please make sure that you watch the trailer that we're going to be playing for you now. It is about a movie called After Earth. We've been telling you about this, and we're running a competition whereby if you hear this keyword that I'm going to give you right now and also see it on our Facebook page, you just need to jump over to learnextra.co.za/After Earth and make sure that you enter the competition. Your keyword is scientist. Scientist. Yes, watch this trailer. See you after this. Welcome back, Mindsetters. Now, that is a must-see. It's coming soon on the 7th of June. If you'd like to win, just like these winners that entered last week, Thursday, such as Mpumelelo Ngema, congratulations to you for winning double ticket for you and your friend to come and watch this movie. And the second winner that we had from last week, Thursday, it is Balani Nkubeko. Well done to you too, Balani. And the last winner that we have is Rofiwa Nemutunzela. Well done and congratulations to you too. If you'd like to win too, make sure that you jump off our Facebook page and also on our entry form, which is learnextra.co.za/After Earth. Your keyword, grade 12s, is scientist. That's what I said, scientist. And now let's continue.
All right, guys, so before that trailer, we were just trying to find the value of x, and all I did was on my calculator, I worked out this value for x, so you should get an answer of x is equal to 4,09 if you do that in your calculator. Okay, now I've had a look at the Facebook page, and some of you were saying, we don't know the question, where did the x come from? Well, if we go back to the question, you will see that they say the radius of the base of the circular cylindrical can is x. Okay, and a lot of you missed that, but they said to you that the radius is x. Okay, so that's where this x was being used all the time. Okay, but remember these notes are posted on the website as well. Okay, last part of the question. They say if the cost of the material is 500 Rand per square meter, what is the cost of the cheapest can? Okay, so if we're talking about 500 Rand per square meter, we're obviously talking about quite a lot of material that's being needed, right? And we're also talking about 430 cubic centimeters, which is quite big. Okay, so you might look at it and say, oh, 500 Rand per square meters, that's a lot of money. We're probably talking about a huge drum. Okay, so they say the cost of the material is 500 Rand per square meter. What is the cost of the cheapest can? Now remember, we worked out the value of x that will give us the cheapest can is 4,09. So if I want to now work out the cheapest cost, what I need to do is I need to take the area that I'm going to have to, the area of material that I need, and I'm going to have to times that, so this is now the total cost. I'm going to have to times that by the cost that they gave me per square meter. Okay, so the area, remember we worked it out before, we worked that out as 2 pi x squared plus 860 over x. So therefore the area was 2 pi x squared plus 860 over x. I think it was actually 2 pi x, and I think my memory is failing me slightly. 2 pi x squared, okay, it was 2 pi x squared. Good. So that's the area in terms of x. I want the area in centimeters, so I need to substitute the value for x that will minimize this area back into my equation. And we've got 4,09 squared plus 860 over 4,09. Okay, Because remember, if we want to get a cost, we need to get the area in terms of centimeters or meters or whatever our units were in this case. So therefore, we're going to put this into the calculator. It's 2 pi times 4,09 squared plus 860 divided by 4,09. And we get our area is 3,154 if I round that off to 1 decimal places. So it was 3,154. So it's 315,4. And let's just remind ourselves if we were working in meters or centimeters here. It was centimeters. Okay, so therefore our area is 315 centimeters squared. Okay, we need to work out the cost. So therefore, the cost now of the cheapest can is going to be this area times by the cost of the material per centimeter square. And remember, they told you that it was 500 rands per centimeters squared. So therefore, I need to times this by 500 to get the total cost. All right. So it's our answer times 500, and that's going to give me 157,000 rand and 687. So it's 157,687 rand. Right, which is quite a bit of money. All right, must be an extremely big can. Okay. Anyway, all right, guys. So I hope that you've been understanding and you've been following along with me. Please, if I've made any errors with calculations and that, feel free to let me know. I might have missed a comma or something like that. Seems like an excessive amount for just one little can, although it's not quite a little can, it's quite a big can, but it still seems like a lot of money. All right, so we've looked at finding maxima and minima, and remember the most important thing I've shown you here is that you can use those two formulae to help you find volume and total surface area. It makes life much easier. At this point, I don't know if we want to go for another break or if I can just carry on with our last question.
You can continue.
Continue.
Yes.
All right. Okay, guys, so this is going to be our last question for today, and this is going to be on rates of change. Okay, so we've had a look at maxima and minima, and we saw that deriving will help us to minimize or maximize certain quantities. Now we're going to look at a rate of change. So let's have a look at what a rate of change is. So we know that a rate of change can be positive or negative. How do we know that? Okay, I'm going to show you with an example. If you have the volume of air in a balloon is increasing, right? So the volume is increasing, and the radius of the spherical balloon is expanding. So that's also really increasing at the same time. Then your rate of change of volume with respect to the radius is positive. Okay, so one quantity is increasing as the other one increases. However, if you've got air escaping from the balloon, then the rate of change is going to be negative. Okay, so important that. So you can either have a positive rate of change or a negative rate of change depending on the question. Okay, some of the other things that you might have noted and you might have come across already, if you see the symbol S of t, that represents an equation of motion. Here we're talking about height, distance, displacement, and so on. Okay, if you see the symbol S dash of t, or the derivative of S at t, that represents the speed if we're deriving the distance, or it's going to be the velocity at time t. You may have come across the second derivative, S at t, which will give you acceleration. All right. So remember, with rates of change, we're really looking at how changing one quantity affects another quantity. So we're quickly going to have a look at a question. We might not have time to finish all of it, so take it down, do it at your own leisure at home. All right. They tell us that the volume of water in a tank is given by V is equal to 5 plus 10t minus t squared. Volume is in meters cubed. T is equal to time in minutes. And they say, find the rate at which the volume is increasing. Okay, so if I want to find a rate at which the volume is increasing, that means that I need to, if we're talking about rate straight away tells me I need to derive this equation. So therefore, the rate of change of volume is going to be given by 10 minus 2t. All I'm doing is deriving this, so I've got 10t, my derivative is going to be 10, and then minus t squared, my derivative is going to be minus 2t. And I want the rate at which volume is increasing when t is equal to 2, so I simply substitute 2 in place of t, and I get 10 minus 4, which is 6. So the rate at which the volume is increasing, it's increasing at a rate of 6 meters cubed. All right. Okay, we might have time to finish the last one. At what time does the volume start decreasing? Now, if you think of this, this is actually a parabola, right? So your volume is doing that. It's increasing up to a point, and then at that point, it's going to stop, and then it's going to start decreasing. So this is the stationary point, okay, if we think of it in terms of graphs. So therefore, if I want, at what time does the volume start decreasing, I need to find out where my derivative is equal to naught, or what value would make my derivative naught. So I take my derivative, which is 10 minus 2t, make it equal to naught, and solve for t, and we get t is equal to 5 minutes. Okay, so therefore, when your time is equal to 5 minutes, or after 5 minutes, your volume then starts decreasing. All right, so hopefully you're all able to understand it with the diagram as well. It makes sense. If you've got a function that you can sketch, it is sometimes nice to do that, because it will show you whether your question is making sense. So we've only got a little bit of time left. I'm quickly going to cross over to Abraham and see if we've got any questions.
All right, so far there are no questions, just comments from the mindsetters, enjoying the show and learning a lot. And it's a nice revision for most mindsetters, because that's what they've been doing and they're still enjoying it. And my plea is that let's also help other mindsetters on the page. If there's someone that you see that is struggling, let's jump over and help them. That's the team.
All right. Okay, guys, so I'm glad that you're all understanding, and this is a very important section in terms of marks that you can get for JAM if you know your formulae. Just remember, if you hear the word maximize and minimize and you have absolutely no idea what to do, derive. Okay, it's always going to work. So if you hear maximize, minimize, least, maximum, that kind of thing, and if you're in a calculus environment, then all you need to do is derive to find your answer. Okay, and thank you so much for joining me with this last section of calculus. I hope that you've had fun over the last 4 weeks and you've learned a lot. Cheers.
Right, thank you very much, Natasha. Mindsetters, I have a few things that I need to tell you. One is that you can catch our special live show on Saturday just for you as a matriculant from 9 o'clock up until 10:30, and also other shows throughout the whole day up until 1:30. But also to enter for the competition, make sure that you also go to our link, which is learnextra.co.za/after Earth. That is the competition that we're having. You could win wonderful double ticket just for you and your friend to come and watch this awesome movie. It's an awesome trailer starring by Will Smith and his son Jaden Smith. The winners for today's show throughout the whole day who entered from last week are: 1, it's Rafiwa Netuzela, Mpumelelo Ngema, and the last one, it's Baleni Ngukane. Thank you very much, guys. We love you so much. Triple M rocks. Mindsetters Maths Monday rocks. Thank you very much.